Hey everyone. Hi. It's so awesome to have all of you here. Today I'll be presenting about tRPC. tRPC allows you to build end-to-end type-safe APIs. But before we dive in, let me give you a brief introduction about myself. So who am I? My name is Anatol. I'm a staff software engineer and tech lead at Garda. At Garda, we love TypeScript. We use TypeScript everywhere, from the front end to the back end to the infrastructure as code. We use TypeScript because it gives us end-to-end type safety, which has allowed us to build products quickly while shipping confidently. And today, I'm excited to share with you one of the technologies we've used, tRPC. tRPC allows you to move super fast while breaking absolutely nothing. So let's get a sense of what we'll be covering today. So first, we'll cover what is the friction of using existing solutions for building APIs. Then I'll show you the true superpower of tRPC via a demo. After that, I'll talk about 4 unique features in tRPC. Number 1 is type narrowing via mirroring. Number 2 is the 10-step React query integration. Number 3 is streaming for AI applications. Then we'll talk about number 4, and that is testing. How are we going to test our tRPC APIs? And lastly, we'll have some key takeaways from today's presentation. So let's start. So what is the friction of using existing solutions to build APIs? Well, you can categorize them into a spectrum. You have very bad to bad. Let's see what I mean by that. Let's start with very bad. So let's say you have a backend endpoint. It returns a list of products. Cool. On the front end, you are duplicating the type of the response. Now, obviously, if you change anything, if you change a property's name and you forget to update the front end, you'll probably get some runtime error because you probably try to access some method on a property you do no longer return. So obviously, this is a terrible solution. I genuinely do not recommend it. So let's see a different solution. Let's talk about Swagger. So no one likes to set up and maintain Swagger. Swagger is a pain. If you want to customize how the SDKs are generated, you have to download all those templates. You have to learn this templating language. You miss like a comma, you're totally screwed. It's a pain. So it's not a good solution. Let's cover some other ones. What about GraphQL? GraphQL, everybody's talking about it. Well, you have to write your resolvers in your favorite programming language. But then you have to learn a new language, the GraphQL language. You define this GraphQL file. You define all the types of the queries, the mutations, the inputs and outputs. And you may be wondering, maybe because I had to learn a new GraphQL language, maybe it'll give you out-of-the-box end-to-end type safety. Well, you are wrong. GraphQL does not give you out-of-the-box end-to-end type safety. And in addition, it brings a whole lot of new complications. For example, rate limiting is no longer trivial. You have very heavy client packages. It's not a good solution. Well, what about tRPC? Well, tRPC allows you to actually build end-to-end type-safe APIs. tRPC has over 1.7 weekly downloads on NPM. It's used by companies like Google, Netflix, and PayPal. But what is tRPC? Well, tRPC stands for TypeScript Remote procedure calls. Now, hopefully, everybody in this room knows what TypeScript is. Otherwise, I don't know what you're doing here. Get out. Okay, so now that we know what TypeScript is, then what is RPC? What is remote procedure call? It's just functions. What do I mean by it's just functions? Well, your client calls a function on the backend. Or at least that's the developer experience you have. That's the developer experience you have. You're just calling the functions. You have input type safety, you have output type safety, but behind the scenes, your RPC framework makes a call over the network, but it's all transparent to you. Everybody knows how to call functions. Everybody knows how to pass input arguments to a function. You have type safety. And so tRPC is an RPC framework built. It's built for TypeScript teams. It's built for teams shipping TypeScript on the front end and teams that ship TypeScript on the back end. And it allows you to move super, super fast. So I want to show you the true superpower here. The true superpower. So let's look at a quick demo. Cool. So I have here a monorepo. On the left, I have the backend code. On the right, I have the client code. In this example, we are working on an e-commerce app. We are returning some products by ID. We have multiple endpoints. What I want you to notice is on the right, we're just calling a function. We're calling the get by ID function. We pass input arguments. We get the output back, and it's fully type safe. But I want to show you the true superpower. So let's see what happens if I rename one of the properties. So let's say I rename name to product name. You can immediately see I have red lines. I have red lines in my IDE. But I want you to notice something even more important. I haven't even saved the backend file. So there's no code generation going on. There's no complex pipelines. It's truly TypeScript native. It works out of the box. Super easy. So I want to show you another feature of tRPC. So let's correct our error, and our red lines will disappear. Awesome. So most of us are probably building pretty big apps. If you're building great products, you probably have pretty large monorepos. What happens if you're inside a specific front-end file? That specific front-end file calls a backend endpoint. But you want to navigate to that specific backend endpoint. So I have a question. Who here can navigate from a front-end file to a specific backend endpoint in under a second? Who can do that?
Create a separate object with all the values there that calls to the specific files with data calls, and then you do the facade.
That sounds complicated, so I'll show you how it is with tRPC. So I hover over the endpoint, and I command click. I command click to go to that specific backend endpoint. Now, does this remind you of something? This is literally navigate to function definition. But this time, it's across the client-server boundary. You get back your IDE powers, superpowers, being able to navigate to functions because it's just functions. Well, what are other IDE features we have? Let's split the screen. Let's look at the backend on the left, the front end on the right. Let's say I want to rename one of my input arguments. So I'm defining a ZOB schema on the backend. Let's say I change my mind because maybe I don't name variables well. I want to change it to a different name. So I'll use the ID feature to rename. I'll say product ID instead. I'll press enter, but I want you to notice I'm currently using the ID here on the front. So I'll press enter, update it on the front end immediately. tRPC brings you back the ID features, but again, across the client-server boundary. So there's more ID features. You've been missing them all along. Let's say I want to rename a procedure or an endpoint. Same thing. I use the ID rename feature, enter what I want to do, press enter, and it was automatically updated on the front end as well. This is how easy it is to use tRPC. Truly a pleasure to work with, believe me. So I want to show you four unique features with tRPC. So let's start one by one. Number one is the type narrowing via middleware. Number two is the Tanstack React query integration. Number three is streaming. How are we going to stream for AI applications? And finally, number four is testing. How are we going to test our APIs? How are we going to test our tRPC APIs? So let's start one by one. Let's start with type narrowing via middleware. So tRPC, like many other frameworks, has advanced features of middleware. You can also associate a user to a specific request. So nothing special. But what is special about tRPC? Well, let's first cover what is not so special about other frameworks. So in tRPC, here is an example of how we would access the user on the request. We get the context object, and it will contain the user. This is all, of course, defined by me. You can see the type. The type of the user is the user type or no. Now, this is very important. So, most applications need protected endpoints. So we only want to allow a user to call our endpoint if they're actually authenticated and authorized. Now, where's the problem? The problem is that with most frameworks, you will define a middleware, you will check if the user exists. If the user doesn't exist, you throw some error. Otherwise, you continue to the endpoint. But the problem is that your type of the user will still be the user type or null. Now, you already checked that the user exists. So why does it have to be null? So let's see how tRPC handles it. So for tRPC, I defined the same kind of middleware. I'll spare you the details. We check if the user exists. If the user doesn't exist, we throw some error, like 401. And then we continue. So now I want you to see what is special about tRPC. Now, if I access the context, you'll see that the user is typed as only the user type. It will never be null. So you may be wondering, what kind of crazy TypeScript features did I use? Like, did I use like generics and types and interfaces? Well, the answer is none of them. This is tRPC type narrowing. tRPC saw that I checked that the user exists, and it was able to narrow down the type of the user. So it gave me absolute type safety. I know the user will always exist. Incredible. So let's talk about the second special feature about tRPC. So we have the Tanstack React query integration. So just as a reminder, here's how we use the client. It's just functions, you pass inputs, you get outputs, fully type safe. But most of us are probably building front-end applications on React. Now, if you're building a React application, you're probably using Tanstack React query, and rightfully so, it allows you to do declarative data fetching. Truly incredible. But what is special? tRPC has a built-in integration with Tanstack. So let's see how that actually looks. So we use the same use query hook that everybody's familiar with, but this time you don't have to remember query keys and query functions. You just get a tRPC helper, fully type safe end-to-end. So we have autocomplete and type safety on the endpoints. We have typed input arguments, And of course, the output of the hook is fully typed as well. But speaking of queries, sometimes we need to update data. So we'll use the use mutation hook from TANSAC React query. And of course, tRPC has an integration with the use mutation hook as well. So here's an example. We are generating mutation options. Again, fully type safe. We get back from the hook the mutate function. Once we call it, we'll have input type safety. It will make sure that we pass the exact input arguments we defined in our backend. Now, I want you to notice, I haven't written a single line of TypeScript. This is not only TypeScript, this is literally JavaScript. I'm not creating any types, I'm not duplicating types, I'm not doing anything. tRPC takes care of me. I am able to write JavaScript code, but tRPC makes sure it's type safe. So speaking of mutations, after your mutation succeeds, now you have some queries that are stale. So you need to invalidate them. And no surprise there, tRPC allows you to end-to-end type safely invalidate queries. You have the endpoints you want to invalidate. You can even invalidate entire routers. You can invalidate even specific endpoints with specific input arguments. It's so powerful. So now that we covered the TANSAC React query integration, let's talk about streaming. Now, most companies these days are building AI applications. So we are using LLM models. But LLM models are quite slow. Like, depending on what model you use, depending on the prompt and how much data they're generating, it can take quite some time for them to successfully finish a response. But we don't want our users' experience to be that slow. We want to do something smarter. We want to stream. So let's see how tRPC allows you to stream. So tRPC uses JavaScript generator functions. Now, for anyone that's not familiar with JavaScript generator functions, they essentially allow you to create iterables. For anyone that's not super familiar with them, you don't need to know anything about them. You just need to know tRPC uses them to allow you to stream type safe. So let's actually see how this works. So we'll use the AI SDK, a model agnostic AI SDK, and we'll get back a text stream from the SDK. This is an async variable. So far, nothing special about tRPC. You're probably doing something similar in your applications. So we can await the async variable. But here's where the magic comes in. We yield. Wherever we yield gets immediately sent to the client. I'll repeat that again. The way you stream is you yield whatever it is you want to send to the client. This is how easy streaming is with tRPC. But wait, we haven't seen the client usage. It must be really complex. So let's see. So here is our tRPC client. Now our output is fully type safe. It's an async variable, and notice it's an async variable of exactly what it is we yielded. I didn't have to write types or interfaces or generics. tRPC just knows exactly what it is I'm returning. So, what about TANSAC React query? Can we use that for streaming? You bet. We use the use query hook, but this time we get an array of exactly what it is we yielded. So your React application will re-render as the stream chunks are coming in, and you can do whatever business logic you want. Super easy. So let's talk about testing. We talked about so many features. You need to test them. And within any API, you need to test your APIs. Please do. So let's see how complicated it is to test with tRPC. You get your client, you get autocomplete for your endpoints, you get input type safety, you get output type safety. I've said type safety like a lot of times this talk, so hopefully like it really drills in. You get full type safety, it's super easy. Now I want to mention something. With most frameworks for building APIs, testing is actually quite difficult. Like you have to bring in all these external packages to mock a bunch of shit. Sorry for the. So why do they make it so difficult to test? Like, everybody needs to test. Why don't they have some like built-in testing? Well, tRPC does, and it's super easy. You don't have to think about the HTTP call. You literally just call a function, input type safety, output type safety. It's that easy. It makes it really easy to test, which is likely to cause you to actually test more, which is a good thing. When things are difficult, you probably tend to do them less often. So testing is good. So now that we covered the 4 unique features about tRPC, let's have some key takeaways from today's presentation. So obviously, there's no cons. No cons. But let's talk about the pros again. So you have truly unmatched end-to-end type safety. I have worked with it for a long time. It's truly magical. You become like a 100x developer. It makes your life super easy. It catches type issues before you ship into production. It's a pleasure to work with. One way it accomplishes this incredible end-to-end type safety is by giving you an amazing developer experience. So the way it gives you an amazing developer experience is by actually bringing back the ID features, but this time across the client-server network. There's nothing like it. You can navigate to the definition of an endpoint with command click. You have renaming abilities across the client-server networks. You can find all the references of a specific endpoint. It's that easy. And then we talked about a bunch of like incredibly unique features about tRPC, and one of them is that there's no boilerplate. We don't have to maintain complex generation pipelines of like cogen and all that bloat. There's no bloat. It's only your code. And then we talked about the React query integration that probably everybody needs. We talked about type-safe streaming because everybody's building AI applications, and it's easy. It's easy with tRPC. And then of course, finally, we talked about testing because everybody needs to test, continue to test, and if you use tRPC, you will love testing. So let's go into some Q&A. I have here the QR codes for the slides. I have the QR code for the GitHub repo if you want to check it out. I also have a QR code to my LinkedIn. So if anybody has any questions, please shoot.
Yeah, I have a question. First of all, actually I have 2 questions. First one, it really resembles gRPC, so I'd like to hear what are the main differences between them. And the second question, if for instance I have multiple microservices, few of them running in Python, others are running on TypeScript, how do I basically utilize the capabilities of tRPC between Python and TypeScript?
Awesome question. So just to repeat the question in case some of you in the back couldn't hear, he's saying, how does this differ from gRPC? What happens if I have like clients or servers in other languages? So the answer is that tRPC was built for TypeScript teams. One of the disadvantages of that is that it doesn't give you end-to-end type safety outside of TypeScript. But it was very intentional because when you try to build multi-language frameworks, you lose a lot of the benefits. Like for example, like you have no boilerplate, you have no code generation, everything shows up immediately in the IDE. So that's one huge benefit, but it's also the drawback. So if you're a TypeScript team, both on the backend and on the front end, this is great. But if you need like other languages, then tRPC was literally not built for it intentionally to really make your developer experience incredible. Any other questions?
I think you didn't mention how exactly do you connect the client and the backend, because I didn't understand how does the system know which functions are linked? Is it just by the naming convention?
Great question. I'll repeat the question. He's saying, this is too much magic. Like there has to be something here. Like how do you get into type safety and all the rest? So let's show you. So this works very, very well in monorepos. Essentially, you have the backend package, you have the frontend package, and you're just importing the type of the backend router. So here you can see I'm importing the type of the backend router, and I'm passing it as a generic to the tRPC client. That's all. That's how tRPC knows immediately exactly what endpoints you have, the input input arguments and output arguments. That's all.
What is the type of this router?
If I hover over it, you will see that it basically is aware of like the get product and all the endpoints. If I actually navigate to it, you'll see that I defined my product router, and I'm literally just exporting the type of that router. So tRPC essentially knows how to take the type and knows how to give you all the autocomplete for all the endpoints and input arguments. Great question.
So this is not the router from the actual backend. This is the router that you connect to initialize the connection between the backend and the frontend. That's not the router that you use for the calls.
Yeah. It's the type of the router. Like you're not actually importing any backend code, you're only importing the type.
One more question.
If you have any more questions, I'm here at the end, so feel free to reach out. And one thing I want to say is that if you are super into building products with really great technology, we're hiring a Gardoc, so if you're interested, talk to me.
What's the company?
Gardoc Health.